Alright, so yesterday we had started going over the 2017 free response questions. We got through 1 and 2, and now we're going to go over 3 through 6. So basically these were the non-calculator problems, so we'll do these without the use of a calculator, but since this 2020 test you're allowed to use a calculator on, you can feel free to use a calculator on any of these. But anyway, I'm just going to jump right in here. So again, it's important to just underline or make note of anything in here that's important to solving the problem. So f is differentiable on the closed interval from -6 to 5. And we also have this information here. It satisfies this negative f of -2, f of -2 equals f of -2 equals 7. We're given the graph of f prime. That's what this graph represents right here. So in order to get to that f of -2, we're going to have to do an integral. So we just got to keep that in mind. We got two line segments. We have a line segment here, semicircle, and then two line segments here at the end. So three line segments in a semicircle. So we're trying to find the value of f of -6 and f of 5. So what we're looking at doing here to start this off with, for f of -6, we need to look at the integral from -2 to -6. The reason why we're doing this is, first of all, we're trying to find f of -6, and we already know -2 because we were given that in the original problem right here. So that's why we're using that in our integral. So of f of x dx. Now, from the fundamental theorem of calculus, we know that this is going to give us, or sorry, not f of x, this would be f prime. So the integral of f prime gets us back to f. So this is going to be f of -6 minus f of -2. And we're going to do a couple of things here to kind of change this around a little bit. First of all, we're trying to solve this for f of -6, because that's what we're trying to solve for, right? Like that's what we're looking for in our question. So first thing we got to do is get f of -6 by itself. So f of -6, I'm going to add that f of -2 over to the other side. So f of -2 not equals, sorry, plus this integral from -2 to -6 of f prime of x dx. Now the problem with this is the problem with this integral is we got to have the smaller number on the bottom. So again, we got one more step of cleaning that up before we start looking at our graph. And again, do this in as few of steps as possible, okay, because we're trying to save some time here. So we're going from -6 to -2, and made another mistake here. Let me, sorry, I'm trying to get used to this tablet, so I'm all over the place here. So when we switch that, remember one of our properties, when we switch that, we got to make this negative. So it's not a plus now, it's a negative. So negative minus sign, now -6 to -2 of f prime of x dx. All right, so this is what we're looking at here in our setup. So this part right here, this f of -2, we were given that in the problem. That's just 7. Okay, we were given that up here. F of -2 is 7. Okay, so that's no problem. The second part here, this after this minus sign, all of this stuff here that I'm gonna put in the box in green, this integral, remember your integral, that's just finding the area under the curve. So from -6 to -2, let me scroll back up here. This area right here, this area is just a triangle. So go back to your geometry formula for a triangle. That's just 1/2 base times height. So if we're trying to find the area of that, you got 1/2, your base is 4, right? 1, 2, 3, 4. Your height is 2. So to find that area there, we're just going to do 1/2. The base, like I said, was 4. The height was 2. So all we're looking at here is 7. 7 minus 1/2 times 4 times 2. That's just 4. 7 minus 4 is 3. So there's the first part. Okay? At any time during this, feel free to pause, write stuff down, whatever. I'm just going to keep moving along. You guys can pause and go back and forth and whatever. The second part, f of 5. Okay, we're trying to find f of 5 for the second part here. So same setup. I'm not going to go through all of these steps over here like I did going from here to here and all that. I'm just going to jump down to this. So f of 5 is going to be equal to f of -2. Now this is going to be a plus the integral from -2 to 5, because in this setup right here, if we're going from -2 to 5, that would already be in order from least to greatest, so we wouldn't need to flip those around to make that negative and do all that stuff. So that's already going to be set up the way we want it, so we don't have to go through those steps. So -2 to 5 of f prime of x dx. All right, so again, f of -2 we already know is 7. Plus, now we got to look at this right here, -2 to 5. I'm going to come back up to our graph. -2 is right here. 5 is all the way over here at the end. So we're actually going to cut this up into 2 segments right here at +2. So we're going to go -2 to +2 and then 2 to 5. So what we're looking at here is this semicircle right here, this part that I have in blue. And then the other part here is this triangle that's above the x-axis. So we got two formulas from geometry. So let's start with the blue semicircle. All right, so first of all, semicircle, so 1/2 pi times the radius squared. Well, the radius was 2, so 2 squared is 4. Now, I left something out here. Because this is underneath the x-axis, it's a negative area, so make sure you got that negative in front of the 1/2 there. And then the last thing we got to add in here, my green area. This is going to be a triangle, so we're going to have that 1/2. The base, let me scroll back up here. Our base here, the base, let me just move some stuff out of the way here so we can see it. The base of this triangle here, we got 1, 2, 3. We count those over there. We got 1, 2, 3, and then the height up here is 2. All right, so base is 3, height is 2. Let me come back down here. Base is 3, height is 2. All right. So there's your different parts. Okay, so I'm going to fill these in here. So we got 7 minus 1/2 of 4, just gives me 2 pi, plus 1/2 times 3 times 2 just gives me 3. So final answer here is 10 minus 2 pi. Okay? All right, now we're going to use both of these numbers, this 3 and this 10 minus 2 pi. Both of those numbers are going to come back in a later problem, so we're going to use them later on. So I don't remember which part it is, part C. So keep those in mind. We'll come back to those later. All right, next part, B. On what intervals is f increasing? Again, this is the graph of f prime. Okay, so when you're talking about f is the integral of this. So we're talking about areas. So on what intervals is the area of this graph increasing? So the integral, the areas are increasing from -6 to -2, and then again from +2 to +5. Okay, because that's where your graph f prime of x is above 0. It's greater than 0. So that's where f would be increasing. Okay, the stuff that's below the x-axis, that's negative. That's a negative area, so that's where it would be. The area would be decreasing. Again, you're thinking going from f prime to f. That's an area. That's an integral. So think about that going backwards there. Okay, part C. Find the absolute minimum. Again, here, keyword, absolute minimum. Remember, when you see the word absolute minimum, we have to, again, look at your endpoints, not just your zeros. So absolute minimums of f. So the minimum values of f are where f prime are 0. So if we look at 0, we have a 0 here. That's -2. And we got a 0 here at +2. But then, because it's an absolute min, we also have to check our endpoints, -6 and +5. Okay, we always did this with a table, so if that's the way we always did it, that's the way we're going to keep on doing it. So now we're looking at f of x, okay, because we want to know the min and max values of f. Okay, that's what we're looking at here, f. All right, now, again, excuse my table here because I'm trying to get used to this new tablet that I don't like using because I'm not used to it, but I'll get used to it. My writing will look a little better. So let me start over here. X. Remember those values from part A because they're going to come into play here. We actually only need to check one of these values. Okay, so endpoints, -6. We already know that. That's from part A. We know that f of -6. We did that up above. That was 3. The next one, -2. Well, we actually already know f of -2. That was given to us in the problem. That's just 7. Okay, if you go back to, let me just come back to this right here. If we look in this right here, we know f of -2 is 7. We already know that part of the table. Next value, this is actually the only one that we have to do anything for. That's 2. And I'll come back to that. I'll do that one. But then the other one is 5. We actually already did that in part A also. That was 10 minus 2 pi. Okay, already did it. We're done. All right, so the only thing we actually really have to do any work for here in part C is this f of 2. Okay, just we need this value right here. We got to fill in this part of the table. All right, so let's do that part here. So f of 2. And look back at your work for part A. This is where I'm getting this work from. Integral from -2 to 2 f prime of x. I don't like that. Let me back up here a second. Let me fix it a little bit. All right, 0 to 2 f prime of x dx. All right. So again, we know f of -2 is 7. We were given that in the problem. The second part of this is your area stuff. So come back up here. We need the area from -2 is right here to 2 is right here. So all we have is that semicircle. So we really basically already did that work. Okay, that's just your -1/2 because it's a semicircle, so half pi times the radius squared. So the radius again was 2 squared is 4. All right, so we pretty much already did this in the part A as well. We just didn't have that extra part of the +3. All right, so there's the rest of our table, 7 minus 2 pi. So we just have to look at our table now and figure out, well, which of these values is the smallest? Is it 3? Is it 7? 7 minus 2 pi, 10 minus 2 pi. So the smallest value here is right there at that part of the table. All right, so that's our absolute min. We just have to now write that. I'm going to abbreviate this. So we got the absolute min at f of 2 is that 7 minus 2 pi. Okay, so that's your final answer there for part C. All right, last one, D. We need to know for each value f double prime equal of -5 and f double prime of 3. Find each of the values, or find the value or explain why it does not exist. So double prime means we need to take the derivative. We already have f prime. That's what we're looking at here in the graph. we need to know, right here is negative 5, right? There's negative 5. Right here's 3. Here's negative 5. We need to find out what the value is at negative 5 and 3 for the second derivative, or we need to say that it doesn't exist and explain why it doesn't exist. So all we need to do is look at these and see, what is the slope of this, because that's the second derivative, is just slope. This is a line. All you got to do is count down, over, just like you did in Algebra 1, down and over, just get your slope, all right? So for f double prime of negative 5, you can look at that segment or the whole thing. It doesn't matter. If you look at the whole thing, you get negative 2 over 4. You look at that section, you get negative 1/2. Doesn't really matter. It's a linear part, so you just count it off. You get negative 1/2. But then we look over at 3, and we can see here that we got a problem, right? Because right there we have that sharp turn, we have a cusp. This is a problem. You should be able to recognize that the derivative is not going to exist right here. So, but we need to be able to show why it doesn't exist using calculus. All right. So, basically, what we're going to do is we're going to do this using limits. Right. So we got to show the left-hand limit is not equal to the right-hand limit. So, if I say the limit as x approaches 3 from the left-hand side, well, if I look at that, that has a slope of 2. And then we look at the right-hand side. The right, as x approaches 3 from the right-hand side. Let's see where I'm at here. As x approaches 3 from the right-hand side, this is going to be a negative 1. So what that means is that since the left hand, the limit as x approaches 3 from the left, does not equal the limit as x approaches 3 from the right, then the limit as x approaches 3 does not exist. Okay, I'm shorthand writing this stuff. I would probably write it out in a little more detail just because you don't want to rely on, does the person grading your test understand what you're trying to say? You don't want to rely on them understanding your chicken scratch. So make sure you write it out with more detail. I'm just giving you my little Cliff Note version. That's what I would say. You want to use limits. Left-hand limit does not equal the right-hand limit, so therefore the limit at 3 does not exist. Okay? There's number 3. All right, number 4. There's a lot of words in here. You guys can read those words. I'm not going to read them out for you there, but basically what we're looking at here in part A, we want to write an equation. Actually, I'm not going to read through the whole thing, but I do want to point out a few things. The internal temp of the potato is 91 degrees at t equals 0. We see that show up down here in another form. Okay, it means the same thing. Basically for this problem here, that's what we're looking at. H of 0, T is your temperature, equals 91 degrees. We're going to be using that in this first problem. So we want to write an equation for the line tangent to the graph of H. Tangent is derivative. We already have a formula for the slope. It's right there. So what we need to do is we need to plug those values in and see what we get. Well, we're going to start off by plugging. We got negative 1/4. H is 91 minus 27. So negative 1/4. This is non-calculator. Keep that in mind. Okay, 91 minus 27 is 64. Negative 1/4 times 64 gives you negative 16. So that's your slope. All right. We're finding this at t equals 0. So we know that when t equals 0, H equals 91. We're given that all over this problem, right here, up here. Okay, so we know that. All right, so we know that the slope is negative 16. Now we got to write an equation. So you go back to Algebra 1 stuff. Y minus 91 equals slope negative 16. T minus 0. That's not even a necessary step there. Just leave it out. Add the 91 over. Negative 16 times t is negative 16t plus 91. Now, don't stop there because we're not finished. We just found the equation of the line. so that we can estimate the internal temperature when time is 3. Okay, so that means that we need to see when time is 3. So after 3, what is it, minutes or seconds? Where are we at here? I don't know. Minutes. There it is. 3 minutes. After 3 minutes, how warm is this potato? Okay, starts at 91 degrees Celsius, and it says in the problem that it will always be greater than 27 degrees Celsius. All right, so we know it's, just keep that in mind. If you get a number less than 27 or greater than 91, you probably made a mistake somewhere, because it starts at 91 and then it starts cooling down to 27 degrees. All right, so negative 16 times 3 is negative 48, plus 91 gives us our final answer of 43 degrees Celsius. After 3 minutes, it has cooled from 91 degrees down to 43 degrees, probably close to the point where you could eat it now. All right. Next, B. We are now trying to find the second derivative, okay? So we have the first part, that we got to find the second derivative. So d squared h over dt squared, that's just the notation for second derivative. So when we take the second derivative, we end up with negative 1/4 times the derivative of h with respect to t is just dh dt. Okay, and we can't leave it like that. We can't leave it like that because we need to fill in something for dh dt. So we come back to our original problem, our original formula, which is negative 1/4 h minus 27. And then we fill that in, clean it up a little bit. It's not negative anymore. Sorry, back it up. We got negative times negative. So this is going to give us now negative 1/4 times negative 1/4 is positive 1/16 times h minus 27. All right, so that's your second derivative. Okay, so now what we were asked, because now we got to answer the question, is this an underestimate or an overestimate? Okay, at times t equal 3. So what we want to know here is, is this an under or overestimate? Looking at part A. So since we know that h minus 27, we know that we know that h was always greater than 27 from the problem. All right, so since that's always greater than 27, then that tells us that this right here is always greater than 0. All right, so h minus 27 has to be greater than 0, so that's positive, right? So since this is positive and this is positive, that means that the second derivative is positive, which means this graph was concave up, which means that our estimate from part A was an underestimate. Okay, it was concave up, looking at our work from part A. Second derivative was concave, or second derivative was positive, meaning concave up, which means that was an underestimate. Okay, so again, just a minute. All right. Now, those two problems right there, this second part B was only worth 1 point, and part A was only worth 3 points. So part C has a lot of work, but again, this is just your separation of variables. It has a lot of work in it, but it's stuff that we spend a lot of time doing, going through separating your variables, taking the integral, finding your value for C, plugging it in, and then finishing it off by plugging 3 into the function. So while there is a lot of work involved in this, there's nothing in here that we haven't done, and we haven't done a lot of. So we're just going to jump right into it and get started. This is what we're going to use later on to find out our value for C. We'll plug in that 0.91 to find out our constant of integration there. So yeah, let's just jump into it here. So dg dt. And I'm going to show every little step so you guys can make sure that you're following along with what's happening here. Again, if you're lost on anything, pause, go back, rewatch it, make sure that you know what's going on. All right, so I'm just going to go through all of this. Okay, so first of all, I'm going to leave the negative over here. Anytime there's something that does not go with that variable that's on the numerator on the left, I'm just leaving that on the right. So g minus 27 to the 2/3 going to the left, dt going to the right. Probably not the most technical way of saying that, but that's how we do it algebraically. So 1 over g minus 27 to the 2/3 dg equals negative dt. All right, so we multiply both sides by dt. Again, probably not the most mathematically correct way of saying it, but algebraically that's what we always do. And now I don't like the left-hand side looking like that, so I'm just going to rewrite this as g minus 27 to the 2/3 dg equals negative dt. All right, so now it looks okay. I'm good with that. I'm ready to go. I'll give myself a little extra work here, a couple extra pages. So, all right, so here we go. Now we're ready. Integrate. Integrate. So here we go. Over here, again, one thing I don't like about leaving it in this form up above here is sometimes we see that and we think, all right, well, I got a variable in the denominator. That's an ln. That's what we don't have that here because we have a power of 2/3. Okay, that only happens when you have a power of 1. So we got to avoid that. So power of 2/3 means we're going to add 1 to it. Oops, I do recognize a problem here. I moved this up from the bottom and I forgot to make that a negative 2/3. All right, so that's good now. So add 1 to it. So g minus 27, add 1 to it. So that's 1/3. And then divide by 1/3. All right. So again, like I've been saying all year, this is a time test. We want to do stuff to avoid wasting time. So instead of dividing by 1/3, instead of wasting time rewriting another step, I wouldn't even do that right from the start. But if you do this, what I'm going to do, instead of rewriting another step, I'm just going to erase this because dividing by 1/3 is the same thing as multiplying by 3. So I'm just going to bring that out front there. Makes it look a lot nicer, but also instead of rewriting in another step, we got it up there. It's all cleaned up. Looks a lot nicer. On the right-hand side, the negative dt, if you want to, I know some people like to put a 1 in there, but either way, the integral of -1 or just a negative is going to be your negative t. And then we're going to put the constant over here. So plus c over here. If you are doing something with an ln or an exponential, you may want to put a subscript of 1 here because that constant will change throughout the problem. We don't have that issue right here, but if you do, you may want to put a little subscript there. Okay, so this is where our point, let me scroll back up here. This point here, 0.91, is going to come in. So we have that point 0.91. So I'm going to plug that in. All right, so that's TG. So they're going to get plugged in here. So 391 minus 27, 1/3, equals -0, or 0, we don't really care about that, plus C. So this right-hand side over here, I'm just going to get rid of that. So I just left with C. Left-hand side, I got a 3. Again, like I said, there's a lot of steps in here, but it's just a lot of algebra work. Once we get down to here, you just got to make sure you're careful with each of your steps. Don't miss out on those little, just the little things in here will trip you up, and you'll miss out on these points. But it's just a lot of little algebra steps in here. So 91 minus 27, we got 64. 1/3 equals C. Many steps is this going to take you? Okay, I know some of you can skip some steps in here and do this a little bit faster. 64 to the 1/3 power, that's just a cube root. Cube root of 64 is 3. I'm sorry, 4. 4 times 3 gives you 12. All right, so we know that our constant is 12. I'm going to take this 12 and come back up to that step right there. All right, so that step, let me make that a different color so it stands out a little better. That step right there, and I'm going to plug it in for C. And then basically what we're going to do is, I solved it for G and then plugged 3 in. I don't know that it really matters. We do want to know what this will be equal to when we plug 3 in for T eventually. But we'll get there eventually. So, okay. Now, back down to this problem. Again, this step right here, I'm just going to recopy this, but instead of a C, I'm going to plug in 12. All right, so we got 3G minus, 27 to the 1/3 equals negative T plus 12. Or you could put 12 minus T. I know some people like to do that so they don't, mix up the minus, and the negative sign kind of runs into the T or whatever. If you want to do that, that's fine. Now, the next thing here, I did this in a couple of steps because I thought it made it easier for saving time. So I just rewrote my G minus 27, and then what I did was this right-hand side, because we could do this pretty easily here, negative T plus 12, and then what I did was I divided both sides by 3, right? So we got rid of this 3 here. Okay, so divide both sides by 3. But then, to get rid of my cube root, the 1/3, I just cubed both sides, so raise them to the 3rd power. So I got rid of this 3 here by dividing by 3, and then I got rid of the 1/3 by cubing. So that's this 3 and this 3 here. Okay, last thing, to get G by itself, final step here before plugging 3 in for T, G of T equals adding that 27 over plus this whole mess, negative T plus 12 divided by 3 to the 3rd power. Okay? Clean that up a little bit. All right, so that is all the work, and I know that's a ton of work. Yeah, hopefully you guys could follow all that and pause it, go back to any of those steps that you're not sure about, getting down to there. So that's just getting our function for G of T. That's just this part right here where it says find an expression for G of T. We didn't even do the second part. Based on this model, what's the internal temperature of the potato at T equals 3? Fortunately, that's the easy part, because all we got to do here is just say, all right, well, I already got my function. G of 3 is equal to 27 plus negative 3 plus 12 divided by 3 raised to the 3rd power. Okay, so the last step, all we have to do there is plug in 3 for T and then simplify. Okay, and 27 plus, so all right, let's talk about this inside here. Negative 3 plus 12, that's 9. 9 divided by 3 is 3. 3 to the 3rd power is going to give me another 27. Internal temperature after 3 minutes is 54 degrees Celsius. All right, so that's a lot of work. That's a 5-point problem out of this 9-point AP. Every AP problem is worth 9 points. This part C is 5 of the points. Part A was 3 points. Part B was 1 point. So there's a lot of points there in that problem. All right, there's number 4. 2 more left to do here. Number 5, 2 particles move along the x-axis. One thing you have to really keep track of here is the particle P, we're given x, which means P is given for position. That's what x is, position. Particle Q, we're given velocity. So just keep track of that while you're working through these problems, because you kind of flip-flop back and forth when we're finding different things with where is it in the position, is it moving left or right, or whatever. So just keep track of that when you're doing this. All right, so part A, for time between 0 and 8, when is p, the particle p, moving left? Okay, so when we're trying to find out when the particle is moving left or right, we need to know where the velocity is 0. So we're going to take this x of p, okay, this x of p, and we're going to figure out what the velocity is. So that means we got to take the derivative, right? So x prime of p of t, which that's not a t. Let me clean that up a second here. Of t, which again, this is the same thing as velocity of p of t, if you want to look at it that way. So when we're doing the derivative of a logarithm, it's 1 over the inside. So the inside is t squared minus 2t plus 10. And then it would be times the derivative of the inside, but you could just put the derivative of the inside up top. So 2t minus 2, right? Because the derivative of t squared is 2t. The derivative of 2t is just 2. So that's the same thing as if we were going to take and multiply by the derivative of 2t minus 2. So just to kind of save you some time, just put that on the numerator. Again, just one of those time-saving things that we would have gone over had we been in class this year during our review. So, all right. Now, we got to figure out where is this 0 or any undefines that we have, okay? So what we need to do is, first of all, decide where, if at all, is the denominator 0 to figure out do we have any vertical asymptotes. Okay, so if we look at this denominator, do we have any vertical asymptotes here with the t squared minus 2t plus 10? Easiest thing to do is to look at your determinant. So if we look at the thing underneath your square root, b squared minus 4ac, if we plug that in, again, you don't really have to do this by hand, just think about it, b squared, so that's going to be negative 2 squared is 4, minus 4 times a is 1, times c is 10. This gives you an imaginary number, which means the entire graph is either above or below, which means the denominator is never going to be 0, so we don't have to worry about that. So all we have to look at is 2t minus 2. Where is this 0? Okay, and that happens when t is equal to 1. Okay, so if we want to know where is it moving left, we have to figure out where is this negative. Okay, so if we factor out a 2, t minus 1, we want to know where is this less than 0, and that's only going to happen whenever we have values that are less than or equal to, I'm sorry, I should say between 0 and 1. Okay, but not including 1 because that's where it's equal to 0. We want to know where is it less than 0. Okay, so that's where it's going to be negative. So that's your answer for that one. It's going to be moving left, right, like that. 0, between 0 and 1. Okay, part B. Same interval, 0 to 8. Find all the times for t which the two particles travel in the same direction. Remember, same direction means same sign on your velocity. Okay, so we're looking for where the velocity has the same sign. All right, so both positive or both negative. So that's what we're looking for. Okay, so first of all, we just did the stuff with the velocity on that last part A. So what I'm going to do is I'm going to start with the velocity for Q. So I'm going to do these color coded, so my velocity, my Q stuff is going to be done in green. So we got Q of t. This one's a pretty nice one to do. We got t minus 5, t minus 3. So we know that this is going to be 0 at 5 and at 3. Okay, so if we're doing a number line for this, we have a couple of things to look at. First of all, we're only going from 0 we got a 3, we got a 5, and we're only going to 8. So that's all we got to look at. So we need some number between 0 and 3 to, decide whether it's going to be positive or negative. So pick any number between 0 and 3, plug it in here, and you're going to get, like if we use 1, we get negative and negative, so that's a positive. Pick a number between 3 and 5, like 4. That's going to be negative, positive, negative, positive, so that's negative. And then a number between 5 and 8, like 6, positive, positive, gives you a positive. Okay? And then again, like I said, in the last one, I'm going to use P, I'll do in blue. So for the particle P, we got 0, and then we only have one thing that we looked at there, that was the number 1, and then 8. So we know that 1, from 0 to 1 was negative, right? We come back here. Everything from 0 to 1 was negative. That was less than 0. We just did that work. So everything from 1 to 8 has to be positive. So we want to know, where do these values, where do the signs match up? Well, from 0 to 1, this is negative, and this one up here is positive from 0 to 1. All right, so that's out. But from 1 to 3, they're both positive. All right, so from 1 less than t less than 3, they're good. And then also from 5 to 8, they're both positive. Okay, so 5 less than t less than 8. All right, so those are the only two intervals that have the velocity has the same direction. They have the same sign, so that's how we know they're moving in the same direction. All right, so that's part B. Part C, find the acceleration of particle Q at time t equals 2. We want to know, is the speed of the particle Q increasing, decreasing, or neither at time t equals 2. And then explain our reasoning. So first of all, at 2, for which one are we looking at here again? Q, that's the green one. So if we look at this at 2 seconds, 2 minutes, whatever time we're looking at here, if we look at that right here, we know it's positive, okay, for the velocity. So remember, we're going to compare that to our acceleration. So we already know that the velocity was positive, okay? So we're going to keep that in mind when we compare this. Is it increasing, decreasing? Because if the acceleration is positive, it's increasing. If the acceleration is negative, then it's decreasing because the signs don't match. So let's look at that. All right, so now the velocity of Q of t, we're going to take the derivative of that. All right, so we're looking at this right here, the derivative of this. So that's 2t minus 8. Okay, so sorry, v prime, because we're doing the derivative to get the acceleration. Right, so acceleration of Q of t. So 2t minus 8. All right, we want to know at time t equals 2, so plug 2 in, right? 2 times 2 is 4 minus 8 gives you negative 4, which is less than 0. So we know, let me separate this off here, we know that the acceleration was negative, right? So since these times here, or I'm sorry, since these signs are not matching, we know that it's decreasing. Okay, they're not the same. One's positive, one's negative. So if they're different, then that means the speed is decreasing. If they were the same, both positive or both negative, then that means it would be increasing. Okay. All right, last one. Last part for this one here. Find the position of the particle Q the first time it changes direction. All right, now, the first time it changes direction. So this first time it changes direction, we did that earlier. That happened at time t equals 3. Okay, because it changed at 3 and 5. Okay, so we did that earlier. The other thing that we need to do here is, if we're trying to find position, We're given velocity. We got to work backwards to position. That means we need to do an integral. All right, so we're going to do an integral, okay, from the first time. So we're going from 0 to the first time it changes direction, which is 3, of the velocity of q. So again, fundamental theorem of calculus, x q of 3 minus x q, that's a 0. Q, there we go, of 0. We're looking for xq of 3, right? So xq of 3 is what we're trying to find. The position the first time it changes direction. That's what we're looking for. Okay, so I'm going to add the q, oops, equals, I'm going to add the q, xq of 0 over to the other side, plus the integral from 0 to 3 of our velocity function. Let me clean that up. Thought after using this thing for 20 minutes it would actually get better, but it doesn't really seem to be getting any better for me. Sorry. Okay, so the first part here, xq of 0, we know from this information right here, x of 5 at time t equals 0. We're given that answer is 5. So we already know that. Okay, we know that this first part here, that's your starting position, that's 5. The second part here is where all the work is being done, because we got to do the integral of this and then plug in 3 to 0. So let's do that. Integral of this up here, the integral of t squared, add 1, divide by your new exponent. So add 1 is 3, divide by 3, minus 8t squared, divide by 2, leaves you with 4t squared, plus 15t. We are going to evaluate this from 0 to 3. Okay, this might not be the correct notation or whatever, but this is how we're going to do it. All right, over here. Again, in as many steps as it's going to take you, we got to simplify all this mess in here. Okay, so all this stuff needs to be cleaned up. All right, plug in 3. 3 to the third power is 27 divided by 3 minus 4 times 3 squared is 9 plus 15 times 3 is 45. If you plug in 0, 0 over 3 is 0, 4 times 0 is 0, 15 times 0 is 0. Again, make sure that you definitely check that, because you don't want to end up with a cosine of 0 and say, well, cosine of 0 is 0, because it's not. Cosine of 0 is 1. So always double check your zeros. Don't just assume that it is a 0, because sometimes it's not. And that's how they trick you. So, 5 plus 27 over 3 is 9. Where's my cursor at? Minus 36 plus 45. Add all of those together, you get your final answer, 23. Okay. Last one, number 6. We got a table, a graph, and a function. There's 3 things here. G of x is a table, h is a function on the graph, f of x is a function right here. So you got a table, a graph, and a function all thrown into one problem. I really think that this could be a potential scenario that you might see on the AP test for this year, because it just kind of seems like it might be something that you would see. It throws all 3, table, graph, function, all into one problem. This is a really good problem that tests a lot of different things: chain rule, product rule, a lot of really good derivatives. Like this, I don't know, this is a really good problem. So I wouldn't be surprised if you saw something similar to this. I don't know, I just really like this problem. So anyway, first thing we want to do is find the slope of the tangent line to the graph of f at x equals pi. Slope of the tangent line means we got to find a derivative of f of x right here. So first thing we're going to do is we're going to take the derivative of f of x. All right, so f prime of x, again, in as many steps as it takes you. The derivative of cosine is negative sine of the inside is 2x times the derivative of the inside is 2 plus e, always just recopy first, sine x times the derivative of the exponent is cosine. I wouldn't even bother cleaning anything up because we're just going to plug pi in and simplify it, right? So first up here, negative sine 2 pi times 2 plus e sine pi times cosine pi. All right, so we got to clean all this up. Now, first of all, first part right here, I recognize sine of 2 pi, that's 0. So this right here is 0. That's out. Next one, this is e. Again, sine of pi is 0, but it's not, the whole thing isn't 0, just the exponent is 0. So e to the 0, which is just 1, times cosine of pi is negative 1. So this is 1 times negative 1. Final answer for part A is negative 1. That's coming back later. Part B, that answer right there is coming back, so don't lose it. Okay, part B. Let k be the function. I tried to recopy these parts that we actually use in each of these, and any answer for f prime of x will be in there. So we will use f of x in this. I don't have it written down here, but we will use that in this function also. So I'll try and pull that up here real quick in my worksheet. Okay, so k is this function right here. This is chain rule. This is just a chain rule function or a chain rule problem. Find k prime. So first thing we want to do to find k prime is take the derivative. So h outside function, h prime of inside function times the derivative of the inside function, f prime of x. Now we're going to plug in pi. Always do your derivative first, then plug in your number later. So h prime of f of pi times f prime of pi. So this is what I said right here. F prime of pi, we already know this answer. We just did all that work in part A. This right here is negative 1. So I'm not even going to waste my time on that. I already know that answer is negative 1 right there. So I'm just going to do that first part, and then I'll come back to that later on and multiply it by whatever I get right here. So f of pi, I'm going to do that one off to the side here. I'm not going to show a whole lot of work for that. That's something, that's pre-calc, that's something you should know how to do. But I'm just going to plug that in over here off to the side so you can see what I'm doing here. So f of pi is, let me pull that up here, cosine 2 pi. So cosine 2 pi plus e sine pi. Okay, cosine 2 pi plus e sine pi. Okay, so cosine 2 pi, cosine of 2 pi gives you 1, and then, well, let me redo this because I think I have the wrong thing written down. Cosine of 2 pi gives you 1 plus, because I think I just had a 0 here for that one, sine of pi is 0, and then e to the 0 is 1, so that should be a 2. And I think I just had a 1 there, so we're going to need a 2 there. So I don't think I had that. So I'm glad I did actually write that down, because I think I messed that one up when I did this problem yesterday. All right, now we got to figure out what h prime of 2 is. Okay, we got to figure out h prime of 2, and that's what we're looking at up here. So right here, 1, 2, right here, this is 2. We need to find h prime of 2. So that's just the slope, that's the derivative. We need to find the slope of that line. So it's just a straight line. So again, we just count, it's down 1, so that's -1, and then over 1, 2, 3. So it's to the right 3. So it's just down 1, right 3. So that one's going to have a slope of -1/3. And we're going to multiply that by this part that we have over here, which is -1. So overall, our final answer for this one is just +1/3. All right, so there's your final answer for part B, 1/3. I don't know why that thing's not going away. There we go, 1/3. All right, now C has a little bit more work involved in it, because we have not only a chain rule, but we have a product rule in there also. So, but again, it's a pretty standard, straightforward. Do you know how to do a chain rule, product rule type problem? So it just has a lot of extra steps in it. So, all right, let's just jump into this one here. So m prime of x. First of all, g prime of -2x times the derivative of the inside is just -2 times the second function, h of x, plus the first function, g of -2x, times the derivative of the second. So let me talk about this real quick, because I know I just wrote it down real fast and didn't explain anything. We have a product rule, right? We got a product right here. So we got to do the derivative of the first times the second plus the first times the derivative of the second. All right, so we did that. Derivative of the first is right here times the second, and then we did first times the derivative of the second. But in doing the derivative of the first, that was chain rule. So g prime -2x times -2, and that, that's going to be something that some people forget about. So don't forget your derivative of the inside. So we got all of those extra steps in there. So just don't forget about them. Don't rush through it. Make sure you got every little piece in there. So from here, we're looking at our table. But before I jump into the table, let me plug in 2. So m prime of 2. I'm going to move the -2 out front. So -2 g prime of -4. You don't really have to do this. You could just jump right into your values, which you probably should do, because this is just wasting time. Okay, but anyway, I just wanted to write that step down there. Okay, so now first one here, g prime of -4. Here's g prime of -4. That's -1. Everybody see that? G prime -4. That's -1 right there. So now I got -2 times -1 times h of 2. H of 2 is the value. Okay, it's not the slope. We already did the slope in the last problem. It's not the slope, it's the value at 2. I know some people are probably looking at that and saying, well, how am I supposed to estimate the value there? Well, you're not supposed to estimate it. You're supposed to figure out what it is. So to figure out what it is, we need to figure out what would this equation of this line be. So we already know the slope is -1/3 x from that last part, the last equation, the last problem. So what's the y-intercept? Well, the y-intercept is 0. It's right here. So y equals mx plus b would just be y equals -1/3 x. So to figure out the value there at 2, all we would have to do is just go ahead and plug in 2 for x. So it's just a -2/3. All right, so that's just going to come down here, negative 2/3. And that's probably the hardest part in this whole problem after your derivative. I mean, it's not even that difficult, but it's one that you really have to think about. All right, now g of negative 4, that's 5, so plus 5 times h prime of 2. H prime of 2, we already did that in the last problem, that's negative 1/3. All right, so now we got a little bit of work to do here, just multiplying. This right here, this first part, negative 2 times negative 1 is 2, times negative 2/3, that's a negative 4/3, minus, because we got 5 times negative 1/3, that's a negative 5/3. Combine them all together, negative 9/3, which is just negative 3. Last one. Is there a number c in this closed interval such that g prime of c is equal to 4? So what we need to do is look at our value from negative 5 to 3. So that's going from here to here. Is there a slope? So first thing I think of is, let's see what happens around this overall slope. So I say g of negative 3 minus g of negative 5 over negative 3 minus negative 5. All right, so g of negative 3 is 2 minus g of negative 5 is 10 over negative 3 minus a negative 5. That's just going to give me 2. So 2 minus 10, that's negative 8 divided by 2, that's negative 4. Well, that's exactly what we were looking for. So if the average slope gives me the slope I'm looking for, then I know it's going to work. So how do I justify my answer? Well, average, another word for average is mean. So what I just did was use the mean value theorem. And that's pretty much all they were looking for there, is that you showed the mean value theorem and justified by saying the words mean value theorem. I would not abbreviate MVT. I would say, yes, there is a value C in the interval from negative 5 to 3 because the mean value theorem shows that it exists. Say something more than that. But that's kind of what you want to say there for that problem. All right, so hopefully those problems make sense to you. And again, you could use your calculators on the test this year for every problem, for both of the problems. Even though these were all non-calculator questions, we didn't use our calculators on them. But hopefully they work. So yeah, so if you guys have any additional questions about any of this, anything that I explained too quickly or not in enough detail, just let me know. Send me a message, send me an email, and I will do my best to explain that to you. But hopefully that makes sense to you with what I did there. So, but yeah, if you have questions, just let me know. Thanks.